Now, okay, then like a tropical quadratic function, let's observe the tropical elliptic paraboloid. As we know, the projected image we obtain if we plot and project it onto xy plane, you can obtain like a tree or cell image like this. And as it now, as you know, as you know, this line is a intersection point, okay? When compared to max 2, okay, in this I will define minimum. This line is also like a quadratic function, tropical quadratic function. Minimum is attained twice. Okay. In this plane, 2x plus 1, that is the minimum. And in the shoes of the x, g equal to x, that is also minimum. Another intersection point is same. That is a minimum of 2x plus, the minimum of g is equal to x, but that is also a minimum of g equal to 1. Okay, so every intersection line means minimum is attained twice. That is very important because of the algebraic geometric sense. I will, in this later of lecture, I'll explain the algebraic variety and the minimum is attaining minimum or maximum twice. I will explain the relation between attained twice and algebraic variety. So, and the most important, another important point is count in this. Let's count vertices, number of vertices, edges, and faces. That is like this. When you think about a cube, we know there are all vertices, 8 vertices, and edge, 12 edges, and 6 faces. Okay, like this. Think about. Let's count the vertices, edges, and faces. But in a tropical world, vertices, instead of vertices, we use tree balance. Because every vertices meets the 3 edges. Okay, that is here, that is here, that is here, that is here. Okay, every edges forms when 3 edges meet. Okay, so use instead of vertices in the tropical world, we use tree balance. So there are 4 tree balance, and Okay, as you know. Delete clearly. There are four edges, trivalence, and edge is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and faces, total 6 faces. 1, 2, 3, 4, 5, 6. That is trivial. There are 6 faces. Okay. Now we can think about if a cube is given. We can think about a dual image. That is octagon, like this. If we think about the this dual image of cube, then edge is just 12, but face and number of the faces and vertices are changed. Face is total 8, and vertices is 6. Okay, so that is so called Poincaré duality between that is octagon, that is a cube. Okay, now we apply this idea onto a tropical curve. Then we obtain, yeah, the following so-called dualization. When you think about dual of the tropical curve, when we can obtain the following image. Okay, here. As you know, for trivalence is, if we think about dual image, 4 faces, and edges, just edges, 1, 2, 3, 5, 4, 6, 7, 8, 9. Okay, 9 edges, and the face is in the dual image of faces, vertices, 3 balances, 3, 4, 5, 6. So total 6 vertices or 3 balances. That is a dual image of a tropical curve. Another interesting example yeah. Like this. It's a long process. And I'm familiar to this note. Okay. If we think about the following tropical curve, here, there, if we count, there are 15 tree balance and 30 edges and 15 faces. Note that between 15 faces, between the faces, these points are surrounded by edges. Okay, we call, in particular, especially we call these faces genus. Okay, so there are 3 genus of 15 faces. Okay, if you think about the dual image of this tropical curve, there are 15 vertices and 30 edges invariant, and 15 faces. Because tree balance and faces are same number, 15 and 15, that would be also same vertices and faces. But because there are 3 genus, okay, there are 3 genus of the faces of the tropical curve, that guys live here. That is a remarkable point of dualization of tropical curve. The genus, if we dualize the tropical curve, genus goes to surrounded by, or in the middle of the triangle pyramid. Okay, like this.